Today we're going to learn about Hess's law. Hess's law allows you to calculate the energies for a reaction if you know the energy for a different reaction. The energy we're calculating is the enthalpy, which has a symbol delta H. That means the heat is measured at constant pressure. So we're measuring how much heat a reaction creates. So first example, calculate the enthalpy, that's heat at constant pressure, for the conversion of 1 mole of graphite to diamond using these two equations. So this is kind of like a little puzzle. When you're making a puzzle, you turn the pieces around until they fit. We're going to do that with these two equations to get what we want. So I'm trying to find graphite as my reactant and then converting it to diamond. So graphite needs to be on the left of my equation. So I see that first chemical equation has graphite on the left. So I'm going to write that down just the way it is. Now I see that I'm trying to convert 1 mole of graphite to diamond. I see that the second reaction has diamond in it, but it's on the left. I need it to be on the right as a product. So I'm going to turn that puzzle piece around. I'm going to reverse that reaction. So I write it in the reverse way. And then our energy for the diamond to CO2 is negative 396 kilojoules. So it would make sense that if you were turning the CO2 back into diamond, it would not release energy. It would in fact take a lot of energy. So I'm going to multiply by -1. And then I check, cross out things that are the same on both sides. So I see that overall the equation is graphite turning into diamond. And then I sum up my energies just as I summed up my chemicals. So that's negative 394 plus 396. So the answer is 2 kilojoules. Here I'm showing how you add up both things. Next example, calculate the enthalpy, that's heat at constant pressure, for 2 solid carbons plus hydrogen gas turning into C2H2, that would be ethane gas. And there's 3 puzzle pieces I can use to put together to get that overall equation. So I see that on the left side I have solid carbon, so I look at my puzzle pieces. I see that there's solid carbon in the second equation there. So I'm going to write that second equation just as it's written with its energy. But look, there's 2 carbons and my puzzle piece only has 1. So I need to double the amount of reactants we're using. So I'm adding 2's. If I'm doubling the amount of reactants, I should make twice as much heat. So I'm going to multiply the energy also by 2. Now I look at my overall equation that I'm trying to make, and I see that there's H2 on the left. So I look at my puzzle pieces, and I see which one has H2. It's the third equation. It's on the left, and there's one of them, and there's one of them I'm trying to get. So I'm going to write down that equation just as it's written, with its energy of negative 286 kilojoules. Now I look at what I'm trying to make, the overall picture. I see C2H2, so I look at my puzzle pieces and I see where C2H2 is. It's in the first equation. It's on the left though. I want it on the right, so I'm going to turn around that puzzle piece, write it down turned around. And the energy for how it's written is negative 1300 kilojoules, so when I turn that puzzle piece around, I need to negate it, so it becomes positive 1300 kilojoules. So now let's add everything up, make sure it goes to the overall, make sure it yields the overall equation I'm trying to find. So I see that I have 2 oxygens in that equation, and I have 2.5 oxygens in that equation. So 2 of those cancel out. I'm writing it here as 4 halves O2, so I can see how they cancel out. And then I see here that the total there in the purple and the blue is 5 halves. Then I have 5 halves O2 down there. So everything cancels out. I see that I have 2 CO2s on the right in purple and 2 CO2s on the left in green. And it looks like that's all it's going to, oh, some H2O. H2O in blue and H2O in green. So then I can add all those together and check it against my overall equation. And yes, I got the same thing, and then I sum up the energies also. And so the answer is 226 kilojoules. Okay, last example. Calculate the heat at constant pressure, that's delta H, for the action of ammonia and oxygen to produce water, nitrogen monoxide, and 1 mole of nitric acid. So, I see that I want ammonia. The equation that I have with ammonia is the first one there. Here I'm going back and writing down that I'm trying to find the overall picture. Then the problem says I can only make 1 mole of nitric acid, so I'm balancing everything to get 1. Okay, so this is what I'm trying to make. I don't really like having those fractions in the coefficients, but it has to be there because I can only make 1 HNO3, the problem says. Okay, so I'm trying to have 2 NH3s in my overall picture. I see that the first equation has 4 NH3s, so I'm going to use that one, except for I'm going to divide everything by 2, including the energy. So that's 2 and 5 halves O2 and 2 NO and 3 H2O. And then the energy would be divided by 2 or multiplied by 1/2. Now I see, let's do the HNO3s. I see HNO3s in my third equation. So I'm going to use the third equation, writing it just how it is, and writing the energy just how it is. Now I see, I'm looking at my overall equation that I'm trying to make, this one I wrote in black. I'm seeing that I have the NH3s, I have some O2s, I have some H2Os, I have some NOs, I have some HNO3s, so it's all there. So I don't really need anything else, but then I'm looking at what I've written and I see that I have NO2, and in what I'm trying to make there is no NO2. So I need to get rid of the NO2. I see that an equation that has NO2 in it that I haven't already used is the second equation. It has NO2 on the right, which is what I want because I want it to cancel out. So I'm going to write that one, except for I'm going to multiply by 3 halves to cancel out the 3 halves NO2 here. So multiplying everything by 3 halves, so I need to multiply the energy by 3 halves. Okay, let's check and see if everything works out or if we need to do some more. So I have the 3 halves NO2 in orange and red that cancel out. I have the 2 NOs, and then in orange I have 3 halves NOs, so 3 halves of those 4 halves are going to cancel out. Oops, I have some in red too. So in blue I had 2 NOs, in red I had 1/2 NOs, so the total there is 5 halves. So then I'm going to cancel out the 5 halves with the 3 halves in orange. So that's going to leave me with 2 halves, or 1 NO. I see that I have a half H2O in the red and 3 H2O in the blue, so half will cancel out, leaving me with 5 halves, or 2.5. I see they have 5 halves O2 in blue, and 3/4 or 6. How would that work? Well, I'll write the blue ones as 10/4. So then 10/4 and 3/4 is 13/4 O2. And that is what I want. So I'm comparing. I have 2 NH3s, 2 NH3s, 13/4 O2, 13/4 O2, 5 halves H2O, 5 halves H2O, 1 NO, 1 NO, and 1 HNO3 and 1 HNO3. So everything's good. I just need to add up the energies, and you wind up with negative 608 kilojoules. So to summarize, Hess's law allows you to find the heat of a reaction. When you know the heats of other reactions, you can add them up like puzzle pieces. So you look at what your reaction you're trying to make, you identify the parts of it, you find where those parts are in your puzzle pieces and the reactions that you can add together. And then if you need to reverse a reaction, reverse a puzzle piece, you negate the energy. And if you need to multiply the puzzle pieces by a coefficient, multiply the reactions by a coefficient, then you also multiply the energies by that coefficient.